Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on the surface area of a cone. If you need any extra help on the surface area of a cone, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 314, there's a dedicated video tutorial there on the surface area of the cone. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at question number 1. Question number 1 says a cone has a base of radius 3 centimeters, a perpendicular height of 4 centimeters, and a slant height of 5 centimeters. And we've been asked to work out the surface area of the cone. And it's a calculated question, so that's quite nice. So to find the surface area of the cone, we're going to need to find the area of the top part of the cone, that curved face on the top. And we also need to find the area of the circle, the base of the cone. So let's start off with the curved face. The curved surface area is pi RL. So that's pi times the radius of the cone, the radius of the base of the cone, times L, which is the slant height. And then we also need to work out the area of the circle on the base. That's going to be pi r squared, so plus pi r squared. So that will give us the surface area of this cone. So in terms of the curved face, the area of the top of the cone, so we're going to do pi RL, so that's pi times the radius of the base, which is 3, multiplied by the slant height, which is 5. So that will give us the surface area of the top part of the cone. And we also need to add on the area of the base, which is the area of the circle, which will be pi r squared, pi times the radius of the base, which is 3 squared. So if we do pi times 3 times 5, that'll give us the area of the top part of the cone, that curved face. And if we do pi times 3 squared, that'll give us the area of the base of the cone. So let's work that out. And when we work that in our calculator, I first of all get 24 pi. So it'll be 24 pi centimeters squared. But I want it as a decimal, so I'm going to give it as 75.398. 2236 and so on, and that would be in centimeters squared. And let's just round this. Let's round it to one decimal place. So to one decimal place, that'll be 75.39. So we'd round up, so it'll be 75.4. So 75.4 centimeters squared to one decimal place. So that's the surface area of that cone. 75.4 to one decimal place, to one decimal place. And that's it. Okay, let's look at our next question, question number 2. So question number 2, we've got this cone and we've got the radius of the base is 4 centimeters and the slant height is 7 centimeters. And we've been asked to work out the surface area of that cone. So to work out the surface area of the cone, the surface area is equal to pi RL. So that will give the area of the top part of the cone, that curved face, plus pi r squared, the area of the base of the cone. And then if you add them together, that'd be the total surface area of the cone. So let's substitute our values. So we'd have pi multiplied by the radius of the base, which is 4, multiplied by the slant height, which is 7. So that part will give us the area of the top part of the cone, that curved face, plus, and then the area of the base would be pi multiplied by the radius of the base, which is 4 squared. And then if we work this out, that'll give us the total surface area of that cone. So let's do that. And when we work that out, we get an answer of 44 pi, or as a decimal number, it's equal to 138.2300 and so on centimeters squared. And I'm going to round that to 2 decimal places, so that'll be 138.23. So the surface area of that cone to 2 decimal places would be 138.23 centimeters squared. And that's it. Okay, let's look at our next question, question number 3. Okay, so question number 3, we've been told a cone has got a base radius 21 centimeters, a perpendicular height of 28 centimeters, and a slant height of 35 centimeters. And we've been asked to work out the surface area of the cone. So the surface area will be equal to pi RL, so pi times the radius times the slant height, that'll give us the area of the top part of the cone, that curved surface, plus the area of the base, which would be the circle, which would be pi r squared. And if we work that out, that'll give us the total surface area of that cone. So let's do that. So it's going to be pi multiplied by the radius of the base, which is 21, multiplied by the slant height, which is L, which is the 35, so 35. That'll give us the area of the top part of the cone, that curved face, plus the area of the base, which would be pi times 21 squared, so pi times 21 squared. And if we work that out, that'll give us the total surface area of that cone. And when we do that, we get an answer of 1,176 pi centimeters squared, or as a decimal number, it's equal to 3,694.512961 and so on centimeters squared. And I'm going to round that. I'm going to round it to 1 decimal place. So to 1 decimal place, 3,694.5 centimeters squared to 1 decimal place. And that's it. Okay, let's look at our next question, question number 4. Okay, so question number 4, we've been given a cone with a base diameter of 12 centimeters, a perpendicular height of 8 centimeters, and a slant height of 10 centimeters. And we've been asked to work out the surface area of the cone. And remember, the surface area of a cone is equal to pi RL plus pi r squared. The area of the top part of the cone, that curved face on the top, which is pi times the radius of the base times the slant height, plus the area of the base, which is pi r squared. So in terms of our values here, well, our r is going to be the radius of the base, which is 6, because it's half of 12, 6 centimeters, going across there. And then our L is the slant height, which is 10. So that means it would have pi multiplied by the radius of the base, which is 6, multiplied by the slant height, which is 10. So that's then going to give us the area of the top part of the cone, plus the area of the base of the cone, which would be pi times the radius, which is 6 squared. And if we work that out, that'll give us the total surface area of that cone. So let's do that. And when we work that out, we get an answer of 96 pi centimeters squared. And then if we write it as a decimal, our answer is equal to 301.59289 and so on. And let's just round that. I'm going to round it to 2 decimal places. So that'll be 301.59. So 301.59 centimeters squared. And that's the surface area of that cone. Okay, let's look at our next question, question number 5. Now, question number 5 is a non-calculator question, so I'm putting it on my calculator. And we're told that a cone has got a base radius of 10 centimeters and a slant height of 18 centimeters. And we've been asked to work out the surface area of this cone and to give our answer in terms of pi. So the surface area of a cone, surface area, is equal to pi RL plus pi r squared. The area of the top part, pi RL, plus the area of the base, pi r squared. So in terms of our values, we've got the radius, which is 10, and we've got the slant height, which is 18. So L is equal to 18 and R is equal to 10. So if we substitute those values in, we'd have pi multiplied by the radius of the base, which is 10, multiplied by the slant height, which is 18, plus, so that's going to give us the area of the top part of the cone, the area of the base, which is pi, multiplied by the radius, which is 10 squared. And then if we work that out, that'll give us the total surface area of that cone. But we need to give our answer in terms of pi because it's a non-calculator question. So in terms of the first part, we've got pi times 18 times 10. So 18 times 10 is 180 pi. So we'd have 180 pi for the first part. And then the second part, we've got pi times 10 squared. 10 squared is 100, so we'd have 100 pi, so plus 100 pi. And then if we do 180 pi plus 100 pi, that's equal to 280 pi. And then it's centimeters squared. So that's the surface area of that cone. And we've given our answer in terms of pi. So the answer would be 280 pi centimeters squared. Okay, let's have a look at our next question, question number 6. So question number 6, we've got a cone and we're told that the base has got a radius of 5 centimeters, the perpendicular height is 12 centimeters and the slant height is 13 centimeters. And we've been asked to work out the surface area of this cone and to give our answer in terms of pi. Okay, so the surface area is equal to pi RL plus pi r squared. So we're going to do pi times the radius of the base times the slant height, and then we're going to add the area of the base, which is pi r squared. So that's going to be pi multiplied by the radius of the base, which is 5, multiplied by the slant height, which is 13, plus, and then if we look at the circle on the base, we've got pi times 5 squared. So pi multiplied by 5 squared. Okay, so let's focus on the top part of the cone. So 5 times 12 is 60, so 5 times 13 would be 65 pi. So we've got 65 pi plus, and then here we've got pi times 5 squared. 5 squared is 25 pi, so we'd have 25 pi. So we've got 65 pi being the area of the top part of the cone, and 25 pi being the area of the base of the cone. So then if we add them together, 65 plus 25, well 60 plus 20 is equal to 80, plus 5 is 85, plus another 5 is 90. So that's equal to 90 pi. So the surface area of that cone is 90 pi. And that's it. Okay, let's have a look at our next question, question number 7. So question number 7 says the diagram shows a cone, so we've got this cone. It's got a vertical height of 20 centimeters or a perpendicular height of 20 centimeters. The radius of the base is 4.5 centimeters and the slant height is y. And part A says we need to work out the value of y. So as you can see here, and it's been labelled as a right angle triangle. We've got a right angle triangle, so if we've got this radius, the perpendicular height and the slant height, this will form a right angle triangle. And if we need to find one of the missing numbers, we can use Pythagoras' theorem to work it out. So here, if we've got the two shorter sides of the right angle triangle, we can use Pythagoras' theorem to work out the longer side, y. Now, obviously, if you needed to find the radius and you were given these two, you could use Pythagoras' theorem and so on. Okay, so let's write down what Pythagoras' theorem is. It's a squared plus b squared equals c squared. So that's Pythagoras' theorem. And then let's label the sides. We've got our right angle triangle. The two shorter sides I label A and B. So the shorter side is A, then the middle side, the middle one is B, and the longer side is C. So A and B are the two shorter sides. Now you could label these the other way around, but it doesn't really matter. So let's substitute in our values. So we've got A squared. So A squared will be 4.5 squared, so 4.5 squared, plus B squared, which is 20 squared, is equal to C squared, which is Y squared. So let's work out 4.5 squared plus 20 squared on our calculator. And that's equal to 420.25. And that's equal to Y squared. So we've just worked out that left-hand side. And now we just need to square root. So if we square root that, we can work out what Y is. So Y is equal to, Y will be equal to the square root of this, which is equal to 20.5. So that means the slant height is 20.5 centimeters. Fantastic. So we've worked out the value of Y, 20.5. Okay, let's have a look at our next part, part B. So in part B, we've been asked to work out the surface area of the cone and to give our answer to one decimal place. So we want to find the surface area of this cone. The radius is equal to 4.5, the slant height is equal to 20.5, and we don't need the perpendicular height, so we've got the radius is 4.5 and the slant height is 20.5, and then we just need to work out the surface area. So let's do that. So the surface area will be equal to pi RL plus pi r squared. The area of the top bit of the cone, that curved face on the top, plus the area of the base of the cone. So pi multiplied by r, which is the radius of the base, which is 4.5, multiplied by the slant height, we've just worked that out to be 20.5, and then we're going to add the area of the base of the cone, which is pi times the radius, which is 4.5 squared. And when we work that out, we'll find the total surface area of the cone, and we just then need to run an answer to one decimal place. So let's type this into our calculator. And when we work that out, we get an answer of 353.4291735. And we've been asked to give our answer to one decimal place. So that would be, if we look at it, we've got 0.429. So because this is 2, we're going to round down. So it's going to be 353.4. So our answer is 353.4 centimeters squared. And that's the surface area of that cone. And that's it. So let's have a look at our next question. So question number 8 says a cone has got a base diameter of 10 centimeters and it's got a height of 18 centimeters, and we've been asked to work out the surface area of the cone. So what I'm going to do is I'm just going to do a little sketch of the cone. So I'm going to do the best I can. So we've got the base, bit of a curve there, and then the bit behind that we won't see, and then it goes up and then down. So that's my little sketch. It's not necessarily the best one, but it's just a little sketch. We're told the diameter of the base is 10 centimeters. So the whole way across from here all the way across to here is 10 centimeters. That means if we turn it into a little right angle triangle, we draw the little right angle triangle with the perpendicular height and the radius, that means the radius is 5 centimeters. So the radius is 5 centimeters. And we also know that the height of the cone is 18 centimeters. So we've got the radius and the height, but we actually want to find the slant height because we need that to find the surface area of the cone. So we need to find out what this is. I'm just going to call it x. So let's use Pythagoras' theorem. A squared plus b squared equals c squared. So A and B are the two shorter sides, so A is going to be 5 and B is going to be 18. You could label those the other way around if you wish, but the longer side, x, is definitely going to have to be C. So C is the longer side, which is x. So let's substitute those values in. A squared will be 5 squared plus B squared is 18 squared equals x squared, which is x squared. Okay, so then if we work this out on our calculator, we get that x squared is equal to 349, just working out what 5 squared plus 18 squared is. Then if we square root, we do the square root of that, we get an answer off. So x is equal to, now you could write this as a decimal if you wanted to, and that would be equal to 18.6815469. I'm just going to write that down, 18.6815469, and you could use that, and that would be the slant height, and that's totally fine if you wanted to use that. Alternatively, you could write it down as your calculator has written down as the square root of 349. So you could use x to be the square root of 349, leaving it as what we call a surd. So you could just use, instead of writing down 18.6815469, you could use the square root of 349. But the most important thing is here, whenever we've worked this out to be the slant height, you don't want to round this answer. So you either use this whole display here of 18.6815469, or use the square root of 349. Okay, so let's write down the formula for the surface area of a cone. The surface area is equal to pi RL, the area for the top part, plus the area of the base pi r squared. So let's work this out. That's going to be pi multiplied by the radius of the base, which is 5, multiplied by the slant height, which is our 18.68154.169. And you could write that out there if you wanted to. I'm just going to do the square root of 349. I'm just going to write that down instead. But you could write the whole thing down if you wanted to. And then close brackets for the first part. And then plus the area of the base, which is pi, multiplied by the radius, which is 5, squared. And then we just need to work this out. And when we work this out, we get an answer of 371.9888787. And I'm just going to round this to 2 decimal places, so that'll be 371.9, and then we've got 88, so we're going to round up, so it'll be 99. So 371.99 centimeters squared, and that's it. Okay, let's have a look at our next question, question number 9. So question number 9, we've got this cone, and the base of the cone is 2 centimeters, and the height of the cone is 5 centimeters. And we've been asked to work out the surface area of this cone. So if we want to find the surface area of the cone, we're going to do, well, actually, if we look at it, we don't know the slant height yet. So we're going to need to use Pythagoras' theorem, using the radius and the perpendicular height to find the slant height to begin with. So let's call this x, and we're going to write down Pythagoras' theorem, which is a squared plus b squared equals c squared. So A and B are the two shorter sides, so A and B, and the longer side is C. So we'd have 2 squared plus 5 squared equals, and instead of C squared, it'd be x squared. 2 squared is 4, and 5 squared is 25, so if we add them together, that'd be 29 equals x squared. It is a calculator question, so you could type that into your calculator if you wanted to. And then you just need to square root, so x is equal to the square root of 29. And you could leave it like that if you wanted to, or you could write out the whole display of what the square root of 29 is, which is equal to x equal to 5.385164.807. I would probably just use the square root of 29, but the most important thing is that you don't round this. If you are using this bottom one, just don't round it. You need to use the whole thing. So that means that x here, the slant height, is equal to the square root of 29, or your 5.385164.807. Okay, and if we go down, okay, we're now asked to calculate the surface area of the cone. So the surface area is equal to the area of the top part of the cone, which is pi RL plus pi r squared. So pi RL, so that'd be pi times the radius of the base, which is 2, times the slant height, which is the square root of 29, or you could use your 5.385 and so on, but just make sure you don't round it. So that's the area of the top part, plus the area of the base, which is pi times the radius, which is 2 squared. And then close brackets. And then we just need to type this into our calculator and work it out. And when you do that, you get an answer of 46.40235.901. And let's just round that to 1 decimal place, that'll be 46.4. So 46.4 centimeters squared. And that's it. Okay, so let's have a look at our next question, question number 10. So question number 10 says, Jonathan has a solid wooden model and he's made it by joining a cylinder and a cone. And we've been asked to work out the total surface area of the wooden model. So in terms of this wooden model, it's got 3 faces. It's got the circle on the bottom. So we'll use pi r squared to work out the area of that circle on the bottom. It's got the curved face of the cone on the top. So we're going to be using pi rl to work out the area of that face. And we'll use the radius of the base of the cone. And we'll use that slant height. And we'll use pi rl to find the area of that curved face on the top. And then we've also got the curved face of the cylinder. And to find the curved face of the cylinder, we'll do pi times the diameter of the circle to give us the circumference of the circle. And then we'll multiply that by 14. Because this is just a big rectangle. If you get a rectangle and you roll it around, you can form that curved face of the cylinder. And in terms of that rectangle, that will be the width, the 14 centimeters. And the length of the rectangle will be the circumference of the circle. So we need to work out the circumference of the circle and times it by 14. And that'll give us the area of that curved face of the cylinder. Okay, so let's find the area of the 3 faces. So let's start off with the easiest one, the base. So in terms of the base, we'll be using pi r squared to find the area of the base, the area of that circle. So we'll do pi times the radius of the base, which is 8, because halfway across the base is 8 centimeters. So we're going to do pi times 8 squared. And when we do pi times 8 squared, we're going to get that's equal to 64 pi, or as a decimal number, 201.0619 and so on centimeters squared. So that's the area of the base of the shape, there, that circle. We've done pi r squared, pi times 8 squared. Okay, now let's do the curved face of the cylinder. So for that, we're going to do pi times the diameter to get the circumference of the circle, and then times it by the height of the cylinder. So that'll be pi multiplied by the diameter of the circle, which is 16. That'll give us the circumference of the circle. And then we'll times that by 14. And that's equal to 224 pi, or as a decimal number, 703.716 and so on centimeters squared. So we've found the area of the base of the shape, we've found the area of the curved face of that cylinder, and now we need to find the area of the curved bit of the cone, that curved face of the cone, so the area of the top of the cone, which is pi RL. So let's write that down. That's pi multiplied by the radius of the base of the cone, which would be, well, the base of the cone, the whole diameter is 16, like the cylinder, they join together. So that's going to be 8, so that's the radius, 8. Multiplied by the slant height, which is 10. And when we work that out, 8 times 10 is 80, times pi would be 80 pi. So 80 pi. Or as a decimal number, that's equal to 251.37 and so on centimeters squared. So that's fantastic. We've now got the area of the base, the area of the curved face of the cylinder, and the area of the top of the shape. And then if we add the three of them together, that'll give us the total surface area of the wooden model. So let's do that. So let's add together 64 pi, 224 pi and 80 pi. Or you could add together these numbers, but I'm just going to use these ones. So 64 pi plus 224 pi plus 80 pi. And as I said, you could add together these if you wanted to, and that's equal to 368 pi. But as a decimal number, our answer is equal to 1,156.106097 centimeters squared. And if we round our answer to one decimal place, that'll be 1,156.1 centimeters squared to one decimal place. And that's it. Okay, let's have a look at our next question, question number 11. So question number 11 says, shown below is a cone, so we've got this cone. The base is a radius of 4 centimeters and the slant height is y centimeters. And the total surface area of the cone is 48 pi centimeters squared, and it's an uncalculated question. And we've been asked to calculate y, the slant height. Okay, so the surface area of the cone, surface area, is equal to pi RL, so pi times the radius of the base times the slant height, plus pi r squared, the area of the base, pi r squared. So we know the answer is equal to 48 pi. So 48 pi, that is the surface area, the total surface area, because we're told that in the question, is equal to pi times the radius times L. So that would be pi times 4 times y. And then plus, I'm just going to put that in brackets for the moment, that's the area, the top part of the cone. And then in terms of the base, pi r squared, so that'd be pi times 4 squared. Okay, pi times 4 squared, well 4 squared is 16, so that'll be 16 pi. So we've got 48, so we've got 48 pi would be equal to, now if we just simplify this, 4 times pi times y would be 4 pi y. You put the numbers at the front, and then symbols like pi next, and then the variables, the y after, plus, and then 4 squared is 16 pi, so plus 16 pi. So we've got the 48 pi is equal to 4 pi y plus 16 pi. Now if we take 16 pi off both sides, so take away 16 pi and take away 16 pi, on the left hand side you'd have 32 pi, and on the right hand side we'd have 4 pi y. Now I'm going to divide both sides by pi, and if I divide both sides by pi they'll just cancel out, so we'll have 32 equals 4y. And if we divide by 4 and divide by 4, if we half it, that's 16, and half again is 8, so y would be equal to 8, so y is equal to 8 centimeters. And that's it. So that's our answer, 8 centimeters. Okay, let's have a look at our next question, question number 12. So question number 12 says the two cones, each with a base of radius 4 centimeters. So each of these two cones have a base radius of 4 centimeters. The distance from here to here will be 4 centimeters. Are joined together to make a solid shape. So we've got this solid shape. AP to BP, so this ratio of AP to BP is the ratio 5 to 3. So the ratio of this distance to this distance is 5 to 3, where AP is the perpendicular height of the larger cone. So if you turn your head sideways, you can see that that would be the perpendicular height of that cone. And if you turn your head this way, the BP is the perpendicular height of the smaller cone. And we're given that AB, so this distance from here to here, is equal to 12 centimeters. And we've been asked to find the total surface area of the shape. So I'm going to start off by looking at this ratio. We've got the AB is 12 centimeters, so here to here is 12 centimeters. and the ratio of AP to BP is 5 to 3. So let's share 12 centimetres in the ratio of 5 to 3, and then we can work out that distance and that distance. So let's do that. So let's add together the parts in the ratio. 5 parts plus 3 parts is equal to 8 parts. So it's 8 parts altogether. We're then going to divide the total, 12 centimetres by 8 parts, so 12 divided by 8 is equal to 1.5. So there's 1.5 centimetres in one part. And then we just need to times it by 5 and times it by 3 to find the length of that bit and the length of that bit. So 1.5 times 5 is equal to 7.5. So AP is 7.5 centimetres. And 1.5 times 3 is equal to 4.5. So that means that BP is equal to 4.5 centimetres. Okay, so we've worked out the perpendicular height of that cone and the perpendicular height of that cone. We know the radius of this cone here, this distance from there to there is equal to 4 centimetres. Now we want to find the total surface area of the shape. So that's going to be that curved face plus that curved face. So we need to work out the curved surface area of the larger cone and the curved surface area of the smaller cone and add them together. And then that'll be the total surface area of the shape. So remember, to find the curved surface area of a cone, we use pi RL, where R is the radius, which is equal to 4 centimetres, and L is equal to the slant height. So we need to find this distance here, let's call it X, and we need to find this distance here, Y, because we need to find the slant height of this cone, and we need to find the slant height of that cone to be able to use pi RL. So let's do that. Okay, so let's start off with this larger cone on the left-hand side. Okay, so we have got a right-angle triangle here with the radius of the cone being 4 centimetres, the radius of the base is 4 centimetres, and the perpendicular height is 7.5, so we've got a right-angle triangle there. So we're going to use Pythagoras' theorem. So A is the smaller side, B is the next over smaller side, and C is the larger side, which is X. So let's write that down, that A squared plus B squared equals C squared. So A squared will be equal to 4 squared plus B squared is 7.5 squared is equal to C squared. So that's going to be X squared. And let's work this out. So when we work out 4 squared plus 7.5 squared, that's equal to 72.25. So 72.25 is equal to X squared. And then if we square root that, the square root of that is equal to 8.5. So X is equal to 8.5. So that means that that distance is 8.5 centimetres. So that's fantastic. We now know the length of that slant height. So we can work out the curved surface area of that cone by doing pi times 4, which is the radius of the base, times the slant height, which is L. Okay, now let's look at the other one. So let's look at this smaller cone. Let's work out what Y is. So we've got the two shorter sides, A and B. Let's label that one B. So we're going to do A squared plus B squared equals C squared. So that would be A squared plus B squared equals C squared. A squared would be 4 squared plus B squared would be 4.5 squared equals C squared, which is Y squared. So let's work this out. And that's equal to 36.25. So 36.25 is equal to Y squared. And then if we square root, we get Y is equal to 6.020797289. So it's not quite as nice as the X, which is 8.5. We get that Y is equal to 6.02079 and so on. And it's important that we don't round that yet because we need to multiply by other numbers, so we don't round that yet. Okay, so now let's work out the curved surface area of this cone on the left and the curved surface area of the cone on the right. So we're going to use pi RL, pi times 4 times 8.5 for this one, and pi RL for the curved surface of that one, so it'd be pi times 4 times 6.02079 and so on. So let's write that down. So it's going to be pi times 4 times 8.5 for the larger cone, plus pi times 4 times our 6.02079 and so on. Okay, so that's what we're going to work out. So we're going to get our calculator and work that out. And when we do that, we get an answer of that's equal to 182.47372204. And that's centimetres squared. And let's just round that. Let's round it to 2 decimal places. That'd be 182.47. So 182.47 centimetres squared to 2 decimal places. And that's it. Okay, let's have a look at our next question, question number 13. So question number 13, we've got this cone and we've got a slant height of 10 centimeters, the radius of the base is x centimeters, and the total surface area is 39 pi centimeters squared. And it's a non-calculator question, so I'm just putting the calculator away. And we're told in part A to show that x squared plus 10x minus 39 is equal to 0. Okay, so let's start off by writing down, well, we know the total surface area is equal to 39 pi. So let's write down the formula for the surface area of this cone. The surface area would be equal to the curved surface area of the top, so that would be pi RL plus the area of the base, pi r squared. And r is going to be equal to x and L is going to be equal to 10. Okay, so we need to show this, so let's write down, but we know the surface area is equal to 39 pi, so we're going to have here 39 pi, the surface area, is equal to pi RL. Pi times the radius of the base, so that's x, times 10. So it's going to be 10 times x is 10x pi, so 10x pi, plus pi r squared, so it's pi times x squared. So pi x squared, just replacing the r with an x. So let's write that down here. 39 pi is equal to 10x pi plus pi x squared. Now what we're trying to show doesn't have any pi's in it, so we're going to divide everything here by pi, so we're just going to divide through by pi, so divide by pi, and we'll get that 39 is equal to 10x plus x squared, just dividing that by pi, dividing that by pi, and dividing that by pi. So we've got the 39 equals 10x plus x squared. Now we just need to rearrange it. So we've got x squared plus 10x on this side, and we just need to take away the 39. So let's take away 39 from both sides. So take away 39 and take away 39. And on the left-hand side, we'd get 0. And on the right-hand side, we'd get 10x plus x squared minus 39. And now we just need to swap these two around. So we get the 0 equals x squared plus 10x minus 39. And then we've shown what we need to show, and that's it. Okay, and then part B. Part B says, hence find the length of the radius. So we want to find what x is. So we've got x squared plus 10x minus 39 equals 0. It says hence, so let's factorize and solve this. So factorizing, hopefully, it's a non-calculator question, so hopefully it factorizes. So we're going to x and x. Now we want to find two numbers that multiply together to give us, so they're going to multiply together to give us negative 39, and they're going to add together to be 10. So I'm thinking 13 and negative 3. So if we have plus 13 and minus 3, 13 times minus 3 is minus 39, and 13 plus minus 3 would be equal to 10, or minus 3 plus 13 is equal to 10. So here we've got that x plus 13 times x minus 3 is equal to 0. So either one of these brackets is equal to 0. So here x is equal to minus 13. So x is equal to minus 13. That would make that bracket 0. Minus 13 plus 13 is 0. Or, in this case, x would be 3, because 3 minus 3 is equal to 0. So it's either one of these two answers. Well, x is the length of the radius, so that one doesn't make sense. So x would be equal to 3 centimeters. X equal to 3. And that's it. Okay, let's have a look at our last question, question number 14. So in question number 14, we've got this cylinder and this cone, and they're joined together to make a solid shape. And we've got some algebraic expressions for the lengths of the sides. Oh, so here we've got the radius of the base to be r, that's quite nice. The height of the cylinder is 2r minus 1, and the slant height of the cone is 3r. And we've been asked to show that the total surface area of the solid shape is 2 pi r brackets 4r minus 1 close brackets. Okay, so what I'm going to do is just find the surface area of this shape, and if we find the surface area of this shape, obviously using the algebra, we should hopefully be able to get it into this format. So let's consider that. So in terms of the surface area of the shape, we've got the base, so we've got the circle on the bottom, we've got the curved surface of the cylinder, and we've got the top of the cone, so that curved bit of the cone there. Okay, so in terms of the base of the cone, so the base of the cone, we would do pi r squared, so it's going to be pi times the radius, which is r squared, so it'd be pi r squared. That bit's quite straightforward. The curved face of the cylinder next, this part here, so the curved bit of the cylinder, curved face of the cylinder. Now we've talked about that previously in a different question, that if you take the circumference of the circle and times it by the height of the cylinder, that'll give you the area of that face. If for instance you were to get an empty toilet roll or an empty kitchen roll, you've got that curved cylinder, that curved face of the cylinder. If you were to cut it vertically, you could lay it out flat and you'd see that you'd have a rectangle. And if for instance you have that toilet roll and you cut it and you rule it out, you'll see it's a rectangle. You'll find that one of the sides of the rectangle is the circumference of the circle and the other side is the height of the cylinder. And then if you times them together, you'll get the area of that curved face of the cylinder. So what we need to do is we need to take the circumference of the circle, which would be the diameter of the circle, the whole way across, that's n over r. So remember, circumference is pi times diameter. So the diameter would be 2r. r plus r is 2r, so that would be 2r is the diameter of the whole way across the cylinder, the whole way across that circle. If we times that by pi, we'll get the circumference of the circle. So it'll be 2r pi, or 2 pi r. So 2 pi r would be the circumference of the circle, and then we need to multiply by the height of the cylinder, which is 2r minus 1. So brackets 2r minus 1, close brackets. Okay, so we've got an expression for the base, which is pi r squared. We've got an expression for the area of the curved face of the cylinder, which is 2 pi r brackets 2r minus 1. And you could expand that if you wanted to. 2 pi r times 2r. 2 times 2 is 4. And then we've got pi, and then we've got r times r is r squared. And then minus, and then 2 pi r times 1 would be minus 2 pi r. So that's another way we could write it. So that's the base, that's the curved face of the cylinder. Now we need to find the area of the curved face of the cone. So that's going to be pi rl, so top of the cone, so the top. And that's going to be pi rl, so it's going to be pi times the radius of the base of the cone, which would be r. It's going to be the same as the radius of the cylinder, so r, multiplied by the slant height, which is 3r. And that means that we have pi times r times 3r. That r times r is r squared, so we've got 3 pi r squared. So 3 pi r squared. So that's fantastic. We now have algebraic expressions for the area of the base of the shape, the area of the curved face of the cylinder, and the area of the cone, the top part here. So we now just need to add them together. So let's write that down. So pi r squared plus, we've got this one here. I'm going to use this one here, which is our 4 pi r squared minus 2 pi r. So that's the area of the base, the area of the curved face of the cylinder, plus the area of the top, which is 3 pi r squared. So we've now got this, we just need to simplify it. So you can add together these like terms here, here, and here. They're all got pi r squareds, pi r squareds, pi r squareds. One of them plus 4 of them plus 3 of them would be 8 of them. So it's going to be 8 pi r squared. But we still have our minus 2 pi r. So we've got our minus 2 pi r, because that one doesn't have a squared, so we can't collect that with the other ones, so we'd have our minus 2 pi r on the end. And finally, we just need to factorize. In terms of the numbers, 8 and 2, well, we can divide them both by 2, so let's take a 2 out. They've both got pi, so let's take a pi out. And this one's got r squared and this one's got r, so we can take one r out, so we'd have an r out. And then if we open up our brackets, this is great, this is what we're trying to get. 8 divided by 2 is equal to 4. We've taken the pi out, and then we had r squared, we've taken out an r, so we're just left with r. So again, that's great. And then minus, and here we've actually taken all of that out, so we're just left with 1. And that's it. We've been asked to show that, and we've shown it. So we've done question number 14, and that's it. And that's it. So in this video, we've gone through the video solutions of the Corbettmaths Practice Questions on the surface area of a cone. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. At the end of this video, I'll put a little icon. If you're watching on YouTube, I'll put a little icon and you can click that and you can subscribe to the YouTube channel that way as well. If you need any extra help on the surface area of a cone, if you go to Corbettmaths and go to video number 314, 314 is a video tutorial on the surface area of a cone. And that's it. So I really hope you found this video useful. Thank you. Cheers. Bye.